Hello everyone, my name is A. Jabali Reddy from CSC AIML A section. Today, my Tech Talk topic name is Affordable Energy Solutions for Developing Communities. Introduction. The World Bank estimates that roughly 1.6 billion people, nearly 1 out of every 4 people on the planet, do not have regular access to electricity. This form of energy poverty disproportionately afflicts people living in developing countries. For example, in sub Saharan Africa, excluding South Africa, 75% of households, some 550 million people, have no access to network electricity. In South Asia, 700 million are similarly not connected to the electricity grid. This shows the importance of saving and also developing affordable energy solutions for a better living. A lack of electricity impacts almost every aspect of human existence: economic, social, health, and education. Without electricity, lighting, most human enterprises are limited to daylight hours. Household chores, homework, reading, and conducting business are stifled. Without electricity, people have only kerosene and candles for cooking and lighting. There are significant safety and health problems associated with kerosene and candles. In 1998, there were about 270,000 deaths from fire related burns in developing countries. In India, almost 2.5 million people suffer burns each year, mainly from overturned kerosene lamps. Energy poverty also tends to disproportionately affect women and children. Without electricity, it is the women that usually collect wood, pump, or fetch water and are exposed to dangerous kerosene and candles that are used for cooking, lighting, and heating. For 780 million women and children, inhaling particulate laden kerosene fumes is equivalent to smoking 2 packs of cigarettes a day, which is very harmful for a human being, which may lead to further lung problems and many other diseases. Market-based solutions. Ending poverty of any type is fraught with challenges. Massive government aid and donations from private charities have made little impact on ending poverty. Despite the US $2 trillion in foreign aid investments since the 1950s, many have argued that these subsidy based aid models fail because they create aid dependent states, promote corruption, stifle competitive marketing, and discourage entrepreneurs. Subsidy models drive tragedy of the common scenarios, in which rational but single minded entities deplete a shared resource, even though it is clearly not in anyone's long term interest to do so. This lack of leadership and trained community ownership has been cited as a reason that donated tractors and drilled wells quickly fail and fall into disrepair. Market based entrepreneurial models have also been championed, notably by Paul Pollack and Dandisa Moyo. The models recognizes that the approximately 1 billion people earning around US $1 per day constitute a $1 billion per day market. These people can lift themselves from poverty if products and services that ultimately increase their income are made accessible to them using market principles. Given the close relationship between access to electricity and quality of life and productivity, there are compelling humanitarian and economic reasons to market electricity to the poor. Demand for electricity. Travel to any developing country or community, and it will not take long to see how electronic devices, mainly cellular phones and radios, have proliferated worldwide. Cellular phones, for example, have a penetration rate of over 61% in the developing world. Far from luxury items, The cellular phones and radios are often used for economic, social, health, and educational reasons. In poor rural areas, cellular phones are a lifeline for all community members to help one another survive, whether for the next meal, medical emergency, or finding the best place to sell produce, while radios convey news and medical alerts. The demand for electricity in developing communities and its humanitarian benefits of improved quality of life and social justice are apparent. What is missing is the means to launch market based, self sustainable, and scalable programs to provide electricity to the impoverished. Community Solutions Initiative. In 2008, IEEE Foundation, together with United Nations and Vodafone Foundations, formed a 3-year pilot study program called the Humanitarian Technology Challenge, HTC. HTC's goal was to have major impact on alleviating global poverty using technological solutions. The solutions are focused on three key challenges in impoverished areas. Those are communications interconnectivity, reliable medical records, and reliable electricity, which are very important for the developing countries nowadays. For the reliable electricity challenge, one team focused on new technology and another team focused on using existing technology, but with innovative community scale implementation using strategic non government organization NGO partnerships. This team was formalized as the Community Solutions Working Group, which would later become the Community Solutions Initiative CSI. The Community Solutions Initiative is now a not for profit member group of the IEEE. It is a volunteer committee organization composed of IEEE and non IEEE volunteers, including students, industry practitioners, principals of nonprofits, academics, and retirees. CSI brings together appropriate technology designs with sustainable business models and scalable implementation to eliminate energy poverty. To make a significant impact on energy poverty worldwide, the implementation of the business plan and technology must be widely scalable. CSI has found success in using strategic partnerships with local NGOs to design and implement the business plans. NGOs often have an embedded presence and are familiar with the communities. The most mature design, business plan, and implementation of the CSI products is the Sunblazer, a portable solar powered generating station currently deployed in Haiti by NGO partner Sirona Cares Foundation. These are the pictures of Sunblazer design, and there's a floor plan of the Sunblazer. And the next one is solar panel system for home. Sunblazer. The flagship CSI product is branded as the Sunblazer. The Sunblazer is a portable community scale solar powered community charging station. 6 Sunblazers have been deployed in Haiti since June of 2011. A franchise style business plan using local entrepreneurs is being used to operate, manage, and develop the customer base for the Sunblazers. A strategic partnership with the NGO Sirona Cares Foundation was formed to implement the program. A new Haitian for profit entity, Sirona Haiti, has been formed to spearhead the in country business, including the manufacturing and all. This is the picture of hybrid power systems. And this is another picture of the Sunblazer. Implementation. Sirona Cares Foundation developed the local entrepreneur teams to take ownership of the first 6 Sunblazer units. Entrepreneurs were found through its ongoing connections with the church and farming communities. Potential franchises must first pass a screening, conduct a formal market survey in their community, and secure customers who agree to lease a home kit. So these are the two pictures of one is of the windmill, means which uses wind energy, and the other one is a bicycle which uses pedal energy. Why not wind? Considerably more energy worldwide is produced each year by wind turbines than by photovoltaic PV panels. Megawatt sized generators to augment grid systems are well established. However, in rural off grid applications, PV panels are the renewable generation source of choice. Since wind power is dominant in grid connected utility scale generation, why is it not also dominant in off grid rural electrification? Since wind turbines are mechanical in nature, there is a tendency to view them as low tech power producers. However, this actually can be an advantage in rural electrification. Wind turbines can be constructed without sophisticated fabrication plants. Mostly local or easily obtainable material are needed, and their operation and field repair is very feasible. So, this can be a very good option. For wind power to be more plausible alternative or auxiliary source to PV panels, advances are needed in eliminating or reducing the need for the expensive and sometimes difficult to obtain rare earth magnets, co-optimizing wind turbine, electrical, mechanical, and tower designs, and performing quick, low technology, and inexpensive wind source assessments. Pedal power. Low labor rates and high unemployment in many developing communities make for the profitable opportunity to use human power to generate electricity. Humans can generate 40 watts of power for a period of 60 minutes by pedaling. Pedaling is also very good for health so that it works both ways. The CSI light cycle is a pedal powered generator that can be constructed for approximately US $240, including a small charging station. A standard bicycle is temporarily connected to drive a 12-volt DC generator. The generator can be used to charge a 12-volt lead acid battery and several banks of 6 1.2-volt NiMH batteries in series. The bicycle can be inserted into and removed from the light cycle stand in less than a minute so that it is readily available for transportation. A reading quality task lamp can be built for US $5 that draws only zero point 0.2 watt. Seaside, after accounting for losses, 1 hour of pedaling can provide 1 hour of light for around 80 homes, which is not a small amount. If a fee to charge a 5-watt cellular phone battery is US $0.20, the light cycle operator can generate income of US $2 per hour. Still in the prototype testing phase, the light cycle could fill a niche market by lowering the barriers for the startup of small independent power producers to less than a few $100s. Wind energy and pedal energy can be used to produce electricity. Thank you.